Hello everyone, good morning, and I hope you all are good and doing well. So, in today's class, what we are going to discuss, as I said earlier, as I informed in yesterday's class, we will be taking up question from Lens. Okay, so before I start giving you questions from this topic, let's have a walk through basic basic formulas that we will be using in today's class for solving questions. Okay, so let's have a look at that. Just give me some seconds. Okay, so what we are basically going to deal with, first thing that we will be dealing with is lens maker's formula. Again, it's not that difficult to understand. I will just make it clear here. Suppose you have a lens, then so we already have seen in our weekdays classes what is lens, right? So lens will look something like this or of different shapes it can be. We already are aware of all those geometries of lens. So this is a lens, suppose, and refractive index of media uh, just bonded within the lens or whatever is there within the lens. Its refractive index is suppose mu L, and this lens is kept in a media whose refractive index is mu M. Then what will be the focal length of lens? Done. So how we can define focal length of lens here? So how we will define that? Let's go with this. So 1 by F is equal to mu media, mu lens minus mu media divided by mu media. ठीक है, ऐसा कुछ लिखेंगे into 1 by R1 minus 1 by R2. Where R1 is what? If light is falling on this surface, then R1 is the radius of curvature of this surface and R2 is radius of curvature of this surface. So this is first surface and this is second. Done. So lens maker's formula, why it is with name itself is clear. It will help those who are making lens. Suppose you visit to some eye specialist and he or she recommended you for using lens of certain focal length. Then what you will do, you will go to some person who can make lens for you, and that person will use this formula to make lens of a particular focal length. Done. So this formula is very much useful for making lenses. How we can rearrange it? Mu L by mu M, we can write it. Mu L by mu M minus 1, we can write. And this will become 1 by R1 minus 1 by R2. Done. So here mu L by mu M is what? Refractive index of lens with respect to media. So that is mu Lm minus 1 by R1 minus 1 by R. Okay? So this is the formula. So this formula we will be using while we will solve questions from lens thing. And second lens formula, that is same as in mirror we studied. There was a relation between object distance, image distance, and focal length. Similarly, in lens also, if this is the lens, and if there is an object kept here, object distance suppose kar lo, we will be measuring from optical center. And suppose this is U, an image is getting formed somewhere here, suppose, and its image distance is V, and its focal length is F, suppose, then relation between U, V, and F will be what? 1 by V minus 1 by U equal to 1 by F. This is the relation. 1 by F, we already know how we can calculate focal length from lens maker's formula. And here we are relating V with V, U, and F together. So this is the equation. Next is your power of lens. So if there is a lens, just imagine here, I'm just going to draw some images or ray diagrams here. So ray of light parallel to principal axis. After refraction, sorry, it is cutting this point here. So this is the focus. Okay. Suppose कर लो second diagram मैंने लिया. Done something like that. Ray of light parallel to principal axis. After refraction, it will cut principal axis at a point called focus. अब आप ध्यान से यहाँ पे देखो, if there would have been no lens, suppose, then in first case, light would have gone in this sense, and in second case, light would have gone in this sense, right? So in both cases, light has deviated by some angle, and here the angle of deviation is this, and here the angle of deviation is this. Similar, simple hai. You can clearly see from the diagram, delta dash is less than delta. So this particular lens, that is lens 1, is deviating light by larger angle, and this is deviating light by smaller angle. And in both cases, we can see when light is getting deviated by large angle, focal length is small. And power of lens is basically the power of a lens to, or capacity of lens to deviate rays. More it will deviate, more it will be powerful. Okay? So power of lens, that is why we will define power of lens as 1 by f, inversely proportional to focal length. See here, lens 1 is more powerful because it is deviating rays by larger angle. Done. So its power can be written as 1 by f. Okay. Similarly here, power of second lens will be again 1 by f. So power we define as what? 1 by focal length. This is how we define power. Okay. Now we have certain number of questions over here. I would love you all to do the question. So please, I'm giving you 2 minutes of time. You don't require this much, but still I'm giving you so that things will sink in your mind. So take 2 minutes of your time and do the question. Okay, do it. The question is very simple. Let me explain it for you first. So question is, there is a biconvex lens. We already know what is biconvex lens. Biconvex lens will look something like this. Okay. And its focal length is given. F is equal to 10 centimeter. It is given. Okay. In two and biconvex lens means something like this. A focal length is 10 centimeter and it is cut into two identical parts along a plane perpendicular to the principal axis. So it is being cut into two identical parts. So if we are cutting it like this, perpendicular to principal axis, we are cutting it. So this is the principal axis. If we have to cut the lens perpendicular to the axis, line will be this dotted line. Okay. So we are cutting it like this. The power of each lens after cutting. Just be like carefully look at the wording of questions. Like what is said there. After cutting, we are getting two identical parts. Is it said like something like this, isn't it? Yes. Two identical parts we are getting. It means what? Uh, Obviously, if we are cutting it like this, one surface will become planar, other will remain curved. And if it is identical, means both these curved parts has they're curved surfaces, and those curved surfaces has equal radius of curvature since they are identical. So this is equiconvex lens. Then ये अगर R है तो ये भी क्या होगा, R होगा. Now you have to tell me what will be the focal length of this single parts. So just use lens makers formula and you will be able to solve the question. तो चलो मैं करके बताती हूँ कैसे होगा. So what is the lens makers formula? 1 by a mu L m minus 1 by R1 minus 1 by R2. ठीक है. So initial focal length is how much? 10 centimeter. Initially, if I calculate, then 1 by 10 will be equal to what? It will be equal to mu Lm minus 1. R1 and R2 ka magnitude is equal, but we need to put values with proper sign convention. So you just see here, incident light is falling on the lens like this. Okay. So incident light is falling like this. Now, what will happen? Radius of curvature, this will become first surface and this will become second surface. I have told you how to identify in lanes first surface and second surface. Just take an incident light. This, if on whatever surface the light is falling for the first time, that will become first surface and another one will become second surface. So this is first, this is second. Now, just see where its radius of curvature will be where, or its center will be where. Here, for first surface, center will be somewhere here. So radius of curvature will be this. This is R, right? So we are measuring it in the direction of incident light. So positive, we are going to take 1 by R minus. Now R2, this is second surface, right? And its center is somewhere here. And we will measure it from this in this direction. From optical center, we generally measure. That is the origin. I have discussed about it in your previous class or previous weekdays class, I must say. So this is the distance of what? R2, radius of curvature for second surface. So we are measuring it in the direction opposite to incident ray. So what will be the sign convention? Sign convention will be this. So this is mu L m minus 1, 2 by R. Okay? So 1 by 10 is equal to this. Now let's calculate focal length of this. Okay? This cut part. So if you're going to calculate its focal length, 1 by f will be equal to mu Lm minus 1. This is not going to change, right? Mu L is same, mu media is same. Just because of cutting, only the radius of curvature of one surface has changed. So for this surface, again incident light मैं ऐसा लूंगी. So this is becoming the first surface, 1 by R minus. Second surface is a plane surface. So its radius of curvature will be what? Infinity. So this is this. Done. So what value we are going to get? Mu L m minus 1 by R. So this is 1 by f equal to this. Okay, so this is the focal length over here. So 1 by f here is equal to this, and 1 by 10 is equal to mu Lm minus 1 into 2 by r. So mu Lm minus 1 by r किसके बराबर है? If I go on to write this, 1 by here 1 by 20. If 2 ko, we are going to bring it here. So it will become how much? 1 by 20 is equal to mu L m minus 1 by r. Done. So this we are going to get. Done. अब आप यहाँ पे ध्यान से देखो, mu Lm minus 1 by r is 1 by 20. So just put 1 by 20 here. 1 by f will become 1 by 20. So new focal length is 20 centimeter. Power will be what? Power क्या होता है? 1 by f होता है. So power is 1 by 20. And always remember, when we write power of a lens, we always write focal length in meter. Just mark it. We always write focal length in meter. So यहाँ पे आप क्या लिखोगे? 20 into 10 to the power minus 2. So this will become 5. And unit of power is what? Diopter. So we just write it or indicate it by capital D. So this is 5 diopter. Okay. So see here also this D is given. So you have to write power in diopter. And for that you have to write focal length in meter. And answer that we are getting for focal length is in centimeter. So we need to change this to meter, right? So this is the answer. Okay. Now let's move on to the next question. So this is your next question. Again, take some 2 minutes, solve it, and let me know what you are getting. Okay, do it. Okay, so let's understand the question first. So two convex lengths of focal length 20 centimeter each are placed coaxially with a separation of 60 centimeter between them. So we are having two convex lengths. Okay, so draw the principal axis, draw it like this, and take another convex length. Okay, so we have two convex lengths of focal length 20 centimeter each. So both are identical basically. From the diagram, it doesn't seem like, but they are identical. So both has a focal length equal to 20 centimeter. Now what's the question is, they are at a separation of how much distance? 60 centimeter. The image of distant object formed by the combination is at what distance from the first lens? So let's call it first lens. Let's call it second lens. So if we are calling this first lens, light will fall on it first, right? So light is coming from where? From distant object. So if object is distant, it means the object is at infinity. And if object is at infinity, light coming will be parallel. So parallel beam is coming. What will happen? It will converge to focus. You know? So let's first discuss about what will happen to this ray because of first lens. So let me take another ray. So this will also go like done. So definitely parallel beam of lights after refraction will converge to focus. So this must be, this distance from optical center of the lens must be equal to how much? 20 centimeter. So first lens is forming the image of distant object as 20 centimeter, right? Now this ray of light will further go through lens that is standing in front of it, right? So what will happen again? Again, it is going here, and this is a convex lens. Light will converge definitely. So it will come here. And similarly, this thing will also happen here. This will come. Now, final image will get formed here. Okay. So for second, now see, for second lens, this is the object. This is the object for second lens, right? And this object distance is how much? From here it is 20 centimeter. Whole separation is 60 centimeter. This distance will be what? 40 centimeter, right? This distance is going to be what? 40 centimeter. So object distance for second lens is how much? 40 centimeter. Focal length is how much? 20 centimeter. Calculate image distance. So we can use lens formula. Use कर लो आप. 1 by v minus 1 by u equal to 1 by f. And 1 by v minus 1 by u is how much? 40 centimeter minus 40. You already know sign convention till now. And focal length, convex lens, positive sign convention, 1 by 20, right? So 1 by v equal to 1 by 20 minus 1 by 40. And this is becoming this. So 1 by 40. V will be 1 by 40. Yani ki from here, this is 40. Again, we didn't require to calculate it also, like object distance for second lens is 40 centimeter. And that must be center of curvature of second lens. I know, because the focal length is 20, then radius of curvature is 40. It means key's object for second lens is at center of curvature. So also image will get formed at another center of curvature. So definitely 40 centimeter. So what is the distance of image getting formed from first lens? Kitna distance hoga? This is 60, this is 40, 60 plus 40, 100 centimeter. So what will be the answer? 100 centimeter. You will see ahead, these all are questions from last 1 or 2 years, right? So you will see ahead also, we will be getting so many questions where we will have combination of lenses or lens or mirror, and there we need to calculate image distance or something like that. Done. So this is a very important part of question that is coming recently. Okay. Now again, take some 2 minutes, read the question carefully and do solve it. Hope you people are doing. चलो करके बताओ क्या आंसर आ रहा है. Okay, anyone done with this? Okay, let's see the question. The radius of curvature of each surface of a convex lens having refractive index 1.8 is 20 सेंटीमीटर. ठीक है, there is a convex lens, equiconvex lens है, क्योंकि दोनों का ही radius of curvature क्या है, same है, and that r is equal to how much, 20 centimeter. Done. And what is the refractive index of the lens? Refractive index of lens is given as 1.8. ठीक है, now the lens is now immersed in a liquid of refractive index 1.5. The ratio of power of lens in air to its power in the liquid. So we need to see what will be the focal length of lens when it is in air and when it is in what? Water, or when it is immersed in a liquid, right? So when the lens is in air, suppose first case में जाते हैं, when the lens is in air. So in that case, what is happening? R1 is equal to 20, R2 is equal to 20, mu lens is equal to 1.8, and mu media is equal to 1. ठीक है, so refractive index of lens with respect to media, mu l by mu n, is equal to 1.8. Done. So what will be the focal length? 1 by f equal to mu l m minus 1, that is 1.8 minus 1, 1 by r1, that is 1 by 20, plus ले रही हूँ, क्यों? क्योंकि if we are taking this as an incident light, what will happen? This curved surface will have center somewhere here. So this is the radius of curvature, right? So this we are measuring in the direction of incident light, that is by plus, minus. And this surface will have radius of curvature, center of curvature somewhere here. So radius of curvature we will measure in this direction, opposite to the direction of incident light, and that is y minus 20. So how much value we are going to get? 0.8 into 2 by 20. That is 10. So this is 8 by 100. है ना? So this thing we are going to get focal length for first. Now let's calculate it for second. When it is in water. So when it is in water, everything is going to remain the same except mu lens is going to be same. Mu media will change, and that is 1.5. So mu lm will change. That is 1.8 by 1.5. Done. So this is going to happen. And if we are going to solve it, 18 by 15. So this will become something like this. So this is 6 by 5. Okay. Now let's calculate the focal length. So this is 6 by 5 minus 1 into 1 by R1 minus 1 by R2. Again, that will remain the same. So this is this. Now, 6 minus 1, that is 1 by 5 into 2 by 20, that is 1 by 10. So this is 1 by 50. Now, what is the power of, we have to calculate ratio power of lens in air. So what is the power of lens in air? What will be that? 1 by f is 8 by 100. Or you can say here focal length is 100 by 8 centimeter. So we need to convert it into meter. If we are going to convert it into meter, this will become how much? This will become 1 by 8 meter. Similarly here, focal length is 50 centimeter. If we are going to convert it into meter, it will become half meter. Okay. So focal length, power of air will be how much? 1 by focal length, that is 8. And power of lens in water will be how much? Again, 1 by 8, that is equal to 2. So what will be the ratio of power in air by power in water? That will be 8 by 2, and that is equal to. Done. So power we always calculate by taking focal length in meter. That is why I did it ideally. Done. But since here we were supposed to deal with the ratio, even if we were not converting focal length into meter, that would have served the purpose actually. But I did it ideally. So that is all. So just step by step I went for making things more clearer to you. So ratio is what? X is to 1. It means Ratio, how much you are getting? 4 is to 1. So value of x is how much? 4. So correct answer will be what? 4. Okay. So another question, not a lengthy question, very easy question it is. So again, I'm going to give you some, chalo मैं 3 minutes देती हूँ. Done? So read the question carefully, try solving it, and let me know the answer. Okay, do it now. किसी को कोई doubt हो in between, you can text me here also on Zoom and also on YouTube. Wait, I'm only. Let me know the answer if you're getting. You know, beauty of ray optics is that if you're really comfortable with drawing the diagram, and also you have like things in your memory also, sometimes what sort of memory you require, like when object position is this, where the image will get formed. If you have that clarity in your head, you will go very much smoothly with your ray diagram. So it's not like the object is given, blindly use whatever rays things you have studied, whatever like 3 rays I have taught you to draw when you have to draw the ray diagram for an object or image formation, right? So don't go with that blindly. You should also have in your back of head where the image is going to get formed. And if you are so much clear about the image position, you will get your ray diagram as very much correct. Okay, so that's important. And how it is important here, I will let you see. I will just take you through that. See here, there are two lenses, right? And there is an object placed in front of two thin symmetrical coaxial convex lens. ठीक है, they are coaxial, means their principal axis is same, and their focal lengths are different. One is having 24 centimeter, another 9 centimeter. So focal length of this is 24 and focal length of this is how much? This is 9. Distance between two lengths is how much? This is equal to 10 centimeter. An object is placed at a distance of how much? 6 centimeter away from L1. Okay, 6 centimeter. So you just see here, focal length is 20 centimeters. So its focal length must be somewhere here. Done. And that is 20 centimeter. It means 24, sorry. So object is kept where? Object is kept in between optical center and focus. And when object is kept in between optical center and focus, what happens? Where the image gets formed, what the information we are having. Like in this case, image formed, sorry. In this case, image formed will be what? It will be virtual. ठीक है. So let's be very much careful while drawing the ray diagram. So चलो मैं यहाँ से I'm just taking it here like this, and image getting formed is virtual, so I will just let light go on like this. ठीक है. Done. So like this I have drawn. Why? Because we have to form the virtual image here, and the virtual image getting formed, like these two refracted rays are not going to meet anywhere. These two refracted rays, after getting refracted from first lens, they're not going to meet anywhere. So let's extend them somewhere behind. So if we are extending them, extending them, they will meet somewhere, right? Somewhere here. So image will get formed here. And then what will happen? Let's first calculate image distance for the first lens. When light is getting refracted by first lens, where the image is getting formed. Let's calculate that. So 1 by V minus 1 by U equal to how much? 1 by A. 1 by V we don't know. U is how much? Minus 6 we will write. Convex lens, so focal length will be positive 24. So 1 by V is how much? 1 by 24 minus 1 by 6. 6 into 4, 4. I'm making denominator same. So this is minus 3 by 64. So this is minus 1 by 8. Yani ki image is getting formed at what distance? At 8 centimeter. So this won't be focus in that case. Okay, focus is 24 centimeter. So image is getting formed somewhere here, 8 centimeter. Done. And now what will happen? This light will now pass through the second lens and it will converge to this point. Because for second lens, you just see here, image object distance will be what? On second lens, incident light is this. And this incident light seems to come from where? From here. So for second lens, this will become object. This is object for lens L2, right? So what will be the object distance for second lens? It is equal to how much? This distance is equal to 8 and this is 18. So this is 18 centimeter. And here the focal length of this lens is 9. Done. Focal length is how much? 9. Done. It means this object, this image for second lens is at its center of curvature. So image will also get formed at center of curvature on the other side. So image will get formed at a distance of 18 centimeter from here. Done. So distance between object and image kitna hoga? Object was here. Final image is here. What is distance between these two? So this is 6 centimeter. This is 10 centimeter, 16. 16 plus 18. So 16 plus 18, if you are going to calculate, you will get 34. So answer will be what? Answer will be 34 centimeter. Okay. Answer will be what? 34 centimeter. Done. I hope it is clear. Now, let's move on to this question. Again, for this also, take some 2-3 minutes of time I'm giving. So somewhere 2.5 minutes you take and solve it. And let me know what answer you get. Should I explain the question for you? Okay, I will just take this privilege. An object is placed on the principal axis of a convex lens of focal length 10 centimeter as shown. Then there is a plane mirror here. So this is a combination of lens plus mirror on the other side of lens at distance of 20 centimeter. Image produced by, oh my god, they will kill me. Image produced by plane mirror is 5 centimeter inside the mirror. What is the meaning of this? That is why I thought to explain the question. So image produced by plane mirror is 5 centimeter inside the mirror. Inside the mirror कहने का मतलब this is a virtual image getting formed and this is 5 centimeter behind the mirror. ठीक है? So this image is virtual ना because plane mirror forms virtual images and virtual image get formed somewhere behind and that behind is not a real point, that is an imaginary point, and that is why it is said image is produced 5 centimeter inside the mirror. Okay, so inside the mirror means behind the mirror. Okay, so now do it. Is it done? Okay, so let's move like this. What is given? The image produced by plane mirror is 5 centimeter inside the mirror. So what will happen actually? This is an object. So it will go like this. This will converge like this. And this converged light will again fall on the mirror. And from mirror, it will reflect back. So this is going to happen, right? So we need to take 2 reach to trace any image. So let's do that. Here it will be like this. And it will again fall on the mirror. And this will reflect like this. And when this reflected light, we are going to extend behind, we will get image here. Done. So this is going to be the ray diagram. Over. This distance is given in the question. This distance is how much? 5 centimeter. So this must be also 5 centimeter from here. है ना? क्योंकि for plane mirror, image distance is equal to object distance. So this is 5 centimeter. Now this will become how much? 15 centimeters. So this is the image distance. So we can easily calculate now object distance. Apply the length formula. So what is the length formula? 1 by v minus 1 by u equal to 1 by f. 1 by v, that is 15 with sign convention, will be plus minus 1 by u. 1 by f. F is how much? Focal length is 10 centimeter. It will be plus 1 by u will be equal to how much? 1 by 15 minus 1 by 10. So if you are going to make denominator same, which is always convenient. So this will become minus 2 by 30, done. Sorry, 60, minus 2 by 60. So this is equal to minus 1 by 30. So U will be equal to how much? 30 centimeter. U is equal to how much? It is equal to 30 centimeter. Okay. So see here how much easy is the question. You didn't require so much concept. Just you need to draw the ray diagram. So you need to have a clarity of how to draw the things. That is very much important in ray optics. And after you are done with that, you need to understand the language of question. Language doesn't mean I'm talking about English. Also, just here in the question, it was given inside the mirror. It means behind the mirror. So we just need to break question step by step, draw the diagram, use the formulas, you will get the answer. So here answer is how much? 30 centimeters. I hope it is clear. Now this is one another question. Please do it, everyone. I'm giving you 3 minutes of time. Okay. I want each one of you to think over it. Think over it and you will reach to the answer. I hope. So take your time, do it. We have some time left, don't worry. So go through it. If you're feeling difficulty in understanding question, you can let me know in the chat section. Okay. Or wherever you're getting stuck, let me know. Be careful in the question because focal length is not given. Instead, what is given? Their radius of curvature is given and also refractive index of the lens is given, and that is same for both, that is 1.75. So actually, we need to apply lens maker's formula to calculate the focal length. Done. And after that, separation between lens is given. Object is where? Object is at infinity. Done. So initial object distance is given, separation is given, their focal length we can calculate. And after that, question is just solved. You just need to apply the formula then. So let me make you understand the question through ray diagram and rest part you will be doing as well. देखो क्या होगा ray of light. So यहाँ पे रे डायग्राम को इजीली दिखाने के लिए मैं थोड़े दोनों लेंसेस को पास पास रखती हूँ. ठीक है, कुछ ऐसे रखती हूँ like this. ठीक है, principal axis you draw. What will happen? What will happen here? Ray of light, object is at infinity, so ray of light coming or falling on the concave lens will be parallel. So this parallel beam of light, you know how we draw rays or refracted rays through concave lens. Done. It will get diverged like this. And after that, this ray of light, since this is a convex lens, it will converge it and it will converge sound. So you need to be very careful with ray diagram. Now, if it will bend up like this. So for first lens, image will get formed where? Image will get formed at its focus somewhere here. Second ray of light you can also draw, right? So second ray of light you can draw like this. Again, this will also pass like this, and then it will converge somewhere here. Okay? So when you will extend second refracted rays backward, you will get here. So first lens will form image at its focal length, and its focal length we need to calculate by using lens maker's formula. For second lens, if I say this will become object for second lens, you know, because incident light on second Sorry, I lost my connection actually. Very much sorry. So what we will do here, if you see carefully, what we will do here, this will become object, what I was discussing. This will become object for the second lens because incident light on second lens is this, and this will seem to come from here. So this will be object distance for second lens. Focal length we can calculate, and then by using lens formula, we can calculate its image distance. Okay. So I hope it is clear and you will solve this question. So that is all for today's class. In next what weekend class, we will discuss the late portion of ray optics, and after that we will move on to next chapter that I will let you know. Okay. So everyone, bye bye, take care, and do calculate its this particular thing. And next class, let me know the answer in tomorrow's weekday classes. Okay. Chalo. Bye bye. Take care. Everyone, stay safe, stay healthy, keep reading, keep enjoying.